Okay, let's start. First question. Okay, stop or go? Homogeneous. Go. So same state. Explain to me why A is wrong. Like go next number. Explain to me why A is wrong. Bailey. Why is A wrong? Because although they're the same state, they don't mix. Okay. Solid, liquid, 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 solid, liquid. Correct answer is C. Number 2, explain or skip. Number 3, explain or skip. Number 4, explain or skip. Skip. 4, Bailey. Okay. Why is this wrong? Okay, for any reaction, it always rapidly happens and then it slows down. Even when increasing in value, it always is exponentially fast and then it slows down for any chemical reaction. Okay. 5, skip. Just stupid mistake. 6, explain. Explain. Okay. Emits. First of all, emits. So we know that emits here could either be A or C, because as it jumps back, it releases energy. This too, no, because it absorbs energy. It doesn't emit, it absorbs energy. Okay, so choose between A and C. Now you know that jump back to energy level 1 is UV, right? Jump back to energy level 2 is visible light. So now the question is the longest wavelength. Remember, long, low. Okay, so which one is of lower energy here? Jump back to visible light or jump back to visible light, right? That's not a big jump. This one is a big jump. And UV is high energy. High energy, high frequency, short wavelength. This one, visible light, lower energy than UV, so longer wavelength. Okay? 7. Skip, explain. Did you get it wrong, baby? Yeah. Okay. It's okay, this girl's real late. So we're looking at emission of hydrogen. Now this seems correct, sure. But you know that it's converging in higher energy, right? So I'm just gonna put here high energy. This is low energy. All right. So letter A. Line M has a higher energy than N. No, I just said it. B. Line N has a lower frequency than line M. So lower frequency meaning no. Low frequency is lower energy than M. Oh, that's also wrong. This is low energy. C. Line M has a longer wavelength than N. It's kind of correct. This is a long wavelength. Then D. Lines converge at lower energy. No, lines converge where? At higher energy. So the correct answer is C. Okay. All right, number 8. Skip, go. Number 9. Explain. Okay. Which statement correctly describes the atomic emission of... Oh, number 8. Number 8. Which statement is correct? So you have here, what is this? Lyman, Balmer, Pashkin. Jump back to UV, visible light. Jump back to infrared. Okay. The arrows represent the transition of electrons to different energy levels when heat is supplied. When you put heat, what happens? They are excited, they move up energy level. So this is wrong. The arrows of W represent the emission in the UV region. Okay, that seems correct. C, the smallest arrow of X represents violet. So the smallest arrow, is this violet? What is that? That's not violet. Red. So wrong. The arrows of Y represents emission with higher energy. Infrared is low energy compared to visible light and UV. That's why you can expose yourself to infrared, you don't die. Expose yourself to UV, you get cancer. It's higher energy. Okay, number 9, stop, go. Yes. 4A. Number 9, skip, go. Skip. Number 10. 10. Increasing from left to right. It becomes smaller from left to right because the proton number increases. So remember, across a period, the protons increase in number, so there's stronger effective nuclear charge, therefore smaller radius. 11. Really, if you get 11 wrong? You're like, Miss, I'm looking at the different periodic table. 12. Did you get this right? But why are we skipping? Remember I told you I never taught you melting point? I taught you down the group. What's the trend of group 1 and group 7? Never mentioned this across period 3. So that just, well, first of all, I didn't teach it, so it's wrong. Second of all, I taught you the groups, not the trends in the period. Third of all, melting point, it depends. Sometimes, well, it increases and then suddenly decreases. That's why it's not part of the trends that we learn. Okay, 13. Stupid mistake. Explanation. Who needs explanation? Sujin, we're good. 13. 14. Skip, really? So, Bailey. Okay. Because if you... Which oxide, when added with water, produces the highest pH? It means basic, the most basic. You know that metals plus water produces basic solution. Which are my metals here? A and C. So I eliminate B and D. Now why A instead of C? Actually, the reason is if you look at your book, this was used as an example. Mg was actually never used because MgO is only slightly soluble to water. So this is the correct answer. And besides, another reason is, so these are the two bases that they form. We will learn in the future that sodium hydroxide is a very, very strong base. So most basic. Okay. 15. Stupid mistake. 16. 17. 17. Okay. So 17. Which statement concerning electron negativity is correct? So electronegativity is the ability to attract electrons. Okay. So, and electronegativity increases From left to right across a period. That's correct. Because nonmetals attract electrons, right? Metals generally have high electronegativity. No, they don't like electrons. It's wrong. C, electronegativity increases on descending a group. On descending a group. Down the group. Wait guys, help here. Electronegativity increases going down. Okay. So electronegativity increases going down a group. Electronegativity increases going down a group. No, it decreases. Why? Less strong effective nuclear charge. It's farther from the nucleus. The noble gases, no, they don't react at all. They don't like electrons, they don't lose electrons. So letter A, Sujin. 18, stop, go. Skip, of course. 19. Unless you didn't have this in your concept map. Or you didn't remember. 19 is just A, straight up. You add an electron to A. Dorothy, Austin, you're done. Neutral gaseous atom. Question with 819. So I have to still check your test. Start working on this, please. These are practice tests. Okay, number 20. Rain, answer is A. I told them this was the example we used in the book. And magnesium, between these two, this is a stronger base. Okay. Number 20, skip, go. Huh? Skip. Skip, go, that's the same. 21.
I know, right? I said go and then
sorry. 21. Oh wait, Sujin, explain or skip? 20. 20? Okay. So which statement is correct? Atomic radius decreases down a group? No, it becomes bigger. More energy levels. So that's wrong. B, first ionization energy decreases down the group? That's correct. Because it's bigger, farther, easier to remove an electron. C, atomic radius increases across period. No, across period it becomes smaller, more protons, more effective nuclear charge. D, first ionization energy decreases across period 3. No, because again it's smaller, it's harder to pull the electrons because there's stronger effective nuclear charge. So wrong. $21. Okay. So always think slowly. Okay, 21. Wait, what do you mean? You answered here, correct?
I circled and
Here,
like the paper.
correct.
Yeah.
And then,
And then I just switched it at the left.
okay, 21. You just have to look at that in the periodic table. What element is this? So slow, guys. Come on, guys. No, what element is this? Neon, 3s2, 3p6, 4s1. Yeah, the first one. What element is this? Guys, what element? 4s1. Why are you even thinking 4s1? Huh? Potassium. Guys. Which are yours? B. What's B? Oh,
That's not
yeah.
nickel.
For A, isn't it like neon is like in front of it? But then,
But it's 4s1. What else is 4s1?
but why is neon in front of it? Isn't it argon? That's like in front.
Well, you can also put, well, he put here neon. You can also do that.
Oh yeah.
So here it's argon for argon 3s2. Wait, if it's neon, yeah, neon 3s2, 3p6, 4s1, potassium. So instead of just putting argon and 4s1, still correct. So you want this.
Yeah.
Okay. Well, this is just a shorter way. This is also fine. How about B? 3D9, what is that?
Is that no? Oh.
What do you think?
No, copper is 3D10 for us. So, and then
Nickel. Correct. Hold on. Well, I'll just put nickel for now. How about C?
it's uranium.
Okay. How about D?
Um,
4s1, 3d5, chromium. Okay. Um, so the correct answer is this is not nickel. So the correct answer is D. Yes, that's the ground state electron configuration. This one, this is not a ground state. This has lost electrons from 4s2. Okay. So if you have their 3d9, where do you lose the electrons first? 3d or 4s? 4s. So if it gave you a 3d9 there, you assume how many electrons has been lost? 2? 1? If it's 3d9, how many electrons have been lost? 3. 2 from here, and then 1 from 3D. So this, although this is a transition element, it's not in its ground state. 3D9 tells me already that it has lost electrons in 4s2. Okay, that's why B, although it's a transition metal, it's not in its ground state. 3D10 4s2.
copper minus
No, 3D10 4s. 1, 2. It can be copper.
copper.
It can be copper because this is copper 1, 2, 3, 3 plus. So it lost 3 electrons. No, but this has lost electrons. If you want ground state, okay, that's zinc. But if it has lost electrons to become 3D9, it was copper 3 plus. Okay, number 22. Skip. Bailey, 22. I'm not gonna skip because you're thinking. All right. So we have sulfur, chlorine, magnesium, aluminium. Okay. Sulfur gains 2 is argon. Chlorine gains 1 is argon. Aluminum 3 plus is neon, right? And Mg2 plus is neon. All right. Decreasing ionic radius. They're the same element. Where am I? My brain is really slowing down. So aluminum is smaller than magnesium. Aluminum is smaller than magnesium. So this is wrong. Smaller. There. Anyway, Bailey, A is wrong. Did I think it right? Aluminium lost 3, so much smaller. Magnesium only lost 2. Okay, so we need, well, this one right away. Next, stop, go. Okay, 24, stop, go. 25, 26, stop. Wait, okay. Period 3, sodium 2, chlorine. What could the vertical axis represent? So it seems like something is decreasing and then decreasing. PCl3. What do you think? So I never taught melting point. Electron negativity of the bonded atom. Ionic radius can be. First ionization energy, no. Electron negativity of the bonded atom. Electron negativity of the bonded atom, never heard. Correct answer is C. Ionic radius, not atomic radius. Why is there a sudden increase here then, miss? Explain this. Because these groups forms cations. These groups forms anions. Cations are always smaller than parent atom. Okay, 27. I considered 2 answers here, B and D. When you subtracted the values. Then 28, 29. That's the same as earlier, right? 30. Okay, let's go order answers. So for short answers, 1A, not everybody got that correct. So everybody else told me what they know, but never didn't answer my question. The question is, you have sodium, you have calcium. We're comparing 2, sodium and calcium. Sodium having 3 energy levels, calcium having 4 energy levels. Why are the colors different? Why? Sodium and calcium. 2, 3. 1, 2, 3, 4. So sodium having 3 energy levels. What will this emit? And what will this emit? Why are the colors different? First answer, they have different energy levels. Another answer, which one will emit? Red and yellow. So sodium is yellow, calcium is red. What's the other answer? Energy levels are different. Electrons move down to lower energy level, 2 marks. Energy levels are different. Electrons move down, not move down. What am I doing? Jump. What's the word? Electrons Electron transition, maybe. Electron transition down to lower energy level. Okay, next. I think only one student got this right. Why is calcium a good conductor of electricity? Everybody said because it's a metal. No, because something to do with electrons. Metals have delocalized electrons. They can easily lose electrons. We have delocalized electrons, or they can easily lose electrons. That's why they're a good conductor of electricity. The rest of you can ask questions for the answers. Yes. But there's easily lose electrons. But it has something to do with electrons. I was just looking for the word electrons. Okay, 2A, increasing trend in ionization energy. Many of you were not using the keywords that I was looking for, but I still considered it. Anyway, I was looking for atomic radius. There's a decrease in atomic radius. Therefore, increase in effective nuclear charge. Harder to pull, harder to remove electrons. Next, melting point. What did I say? So why does it decrease down the group? Lithium to cesium, you have more energy levels. Electrons farther from the nucleus. What's the opposite of strong? Weaker. Effective nuclear charge. Because of what? Shielding. Therefore, less metallic bond. All right, reaction of phosphorus with water. This was in the book, right? Okay. But plus water is it H3PO4? I don't want to think. Brain, can I borrow your test short answer? Aqueous. All right, is this balanced? Please balance for me. Thank you. Four is the balance. Everybody else, please copy. It's phosphoric acid. Okay. Everybody got this correct. Let's look at formulation of equation again. So we have MgO in water. You know this is solid. It's liquid. And you know it forms a base. So magnesium hydroxide. Is this balanced? Seems balanced. Aqueous solution. Always write. You mean the state symbol? Always write the state symbol. How do you know? Well, we've been experimenting on it. Acids base, you know, are solutions, so aqueous. Water, you know, it's liquid. MgO, the powder that we burnt, that was solid. Okay. Atomic radius across period 3, increase, decrease. Describe first and then explain. So you say that atomic radius, decrease, explain. I was looking again for number of, increase in number of protons. Therefore, increase effective nuclear charge. That's it. And the rest of your explanation, okay. Everybody got this correct, I think, if I'm not mistaken. Phosphorus, it lost an electron, therefore it should be smaller. So evaluate this hypothesis. It would probably be between this and this. This is invalid because it should be smaller than parent atom. What's the size of phosphorus? 109. Parent atom, which is your phosphorus, is about 109. Therefore, P3 plus should be smaller than 109. Next. I think some got this correct, not all though. So we have sodium and sulfur. Sodium, sulfur forms, then combine the two, NaS, but wait, sulfur is -2, so that's Na2S. Balance equation is 2Na. Okay. State symbols if you want. Solid, solid, solid. This can also be aqueous. Okay, so electron arrangement. You got that correct, but some of you got this wrong. Make sure sodium here is plus, so it lost an electron. Sulfur is 2 minus, so it gained 2 electrons. So this should be 1s2, 2s2, 2p, 6. 3s1, you lost that electron. Sulfur, 1s2, 2s2, 2p6, 3s2. Instead of 3p4, it's 3p6. You've gained 2 more electrons for sulfur. You added here, and then you lost. Tell yourself. Okay, so we have here Cr2O3, which tells us probably this is +3, and this is -2. So therefore, if it's +3, what's the name? Chromium 123 oxide. I'm sad. Some of you forgot how to name. Why can't I name it dichromium? Rain? Dichromium? Okay, remember the prefixes are only for metals, non-metals. Okay, some of you also put
I forgot
or chromium oxide. You forgot the Roman numeral. Made me kind of sad. First ionization energy, I'm also sad. Only one person got it correct. Bailey got it correct, right? Very good, Bailey. Guys, I said you're gonna get this wrong on the test. Am I right? Yes. 1 mole of electrons from 1 mole of neutral gaseous atom. Yeah, but mole of electrons. Okay. Why is the first ionization of magnesium higher than sodium? What am I looking for here? Magnesium has higher number of protons, therefore higher effective nuclear charge. Therefore, okay, and higher energy required to remove electron. Okay, straight up from the book. sodium, sulfur, so sodium oxide in water produces NaOH. Balance the equation, please. How it's balanced. Sulfur trioxide in water, sulfuric acid. That's balanced already. Okay. Deduce the equation and so acidic. Oh, this is basic and sulfur acidic. Somebody switch this. Metal forms basic. Non-metal forms acidic solution. I bet you can't wait for number 8. Okay, 3 marks. Sodium to, well, generally, acidic to basic, but hold on, also mention amphoteric, which is your aluminum. But it says for each of the elements. Each of the elements. So 1 point, sodium, magnesium, acidic. Aluminium, amphoteric. Silicon to chlorine, basic. Can you please change your answers if I put it right but you didn't put the elements? I need the elements. Okay, last. It's an experiment that you have to understand first before you can answer the following questions. So we have, you know, eggshells contain calcium carbonate. If you powderize it, you don't, actually I was telling Heavy, don't throw the eggshells, it's calcium carbonate. Okay, so you have eggshells and you added hydrochloric acid to ensure that calcium carbonate has reacted, so it will react with the acid. Then the excess acid left was titrated with NaOH. So in your brain, you should imagine you have some amount of your eggshell, and then you pour acid into the beaker, and it should have reacted with the powder. And then you took some amount of that acid. This will become a solution now once it reacted with calcium carbonate. So you got some of the solution of that and titrated it with NaOH. Now, imagine if this calcium carbonate, if it completely reacted with HCl, this shouldn't be acidic anymore. There's no more HCl anymore. So we don't know. So what we did was we took a sample, titrated it with NaOH to see whether this is still slightly acidic. In other words, you want to check if there is excess HCl that did not react completely with calcium carbonate. So a student added this much of HCl to this grams of your eggshell. Calculate the mole of HCl added. So, you know concentration is N over V, therefore mole is concentration times volume. What's the concentration of HCl? It's given 0.2. What's the volume? 27.20 cm cubed. Convert that to dm cubed. So 0.0272 dm cubed. What's the mole? Please look if you got it right. 544 mole of HCl. I was happy everybody got that correct. B. The excess acid, this one, requires this volume and concentration of NaOH. Calculate the amount in mole of the acid that is in excess. So what is the mole of the acid here when I titrated it with sodium hydroxide? Concentration equals N over V again. Mole equals C times V. What is the mole of the base that we added? The mole of sodium hydroxide. Concentration is 0.1. Volume is 0.0238 dm cubed. So what is the mole of the base? That's mole of NaOH. Now how do I know the mole of the acid? Well, you actually need a balance equation. HCl plus NaOH forms water plus NaCl. So the balance equation, 1 mole of HCl reacts with 1 mole of NaOH, right? So, if we have 0.0238 mole of NaOH, 1:1, it means you also have 0.00238 mole of HCl. Okay, questions for B? This is where you got lost for C. The question is, determine the amount of HCl that reacted with calcium carbonate in the eggshell. This is my excess, right? The total mole of acid that I mixed with calcium carbonate is 0.00544. So, how much reacted with calcium carbonate? If this was in excess, how much from the total reacted? Common sense, 0.00544 minus 0.00238, which is what? 0.00306. Do we understand this part? Because everybody got lost on that part. The total mole of my acid when I mixed it with calcium carbonate was 0.0544. And then, some didn't react. This one didn't react because this was able to react with sodium hydroxide. It means this was in excess. So this minus didn't react, this 0.00306. So this is letter C. Letter D, I gave that to you, 1:2. Letter E, determine the amount in mole of calcium carbonate in the sample eggshell. Many of you, I don't know, used grams per mole. Determine the amount of mole in calcium carbonate in the sample eggshell. So if this is 0.00306 mole of HCl reacted with calcium carbonate, how many moles of calcium carbonate was in the eggshell? Looking at the balance equation that I gave you for letter D, for every 2 mole of HCl, you have 1 mole of calcium carbonate. So just divide this by 2. Correct answer is 0.00153. To those who got that correct, and you see the word ECF, it means error carried forward. I just give it correct. But please know this is the correct answer. I gave it correct because you got C wrong. You didn't subtract. Any question with a solution? You good?